All right. This chapter on production cost is not going to be covered on the test one. And as a matter of fact, this chapter, there will be no questions from this particular chapters on any tests, whether it's test one, test two, or the final. However, you need this chapter in order to understand the chapter on perfect competition, monopoly, monopolistic competition, and oligopoly. So we will make use of this chapter in other chapters that will be covered on the test too. So for now, don't worry about this chapter and this test. There will be no questions from this chapter on this test, but it has to be covered anyway. Okay. So we're gonna talk today a little bit about production costs. It's not a terribly long chapter, so probably it's gonna be about half an hour or so. And it's fairly straightforward. So let's talk about production costs. So chapter 22, production costs. And there are two types of basic costs. One is the fixed cost. Fixed cost means that it stays the same. It doesn't change no matter what the output is. So whether the output is 0 or 1 or 100 or 1,000, this cost stays the same. Obviously, an example of cost like that would be something like the lease that you pay, okay? Rent or phone or something like that. It doesn't matter what the output, the cost is going to stay the same. So fixed cost stays the same regardless the output. Okay. And then we also have variable cost. Obviously, variable cost is going to vary with output. And if we add them together, if we add the fixed cost and the variable cost, we're going to come up with something called total cost. So total cost is just the sum of fixed cost plus variable cost. So if I was to write a formula, we have that total cost is equal to fixed cost plus variable cost. Now, let's take a look at what the graphs would look like for those types of costs. Well, here are the costs, and here's the output. Q stands for output. However many units we're producing, whether it's 0, a million, a billion, whatever. Okay. So the fixed cost is the easiest one to come up with. Obviously, it's fixed. It stays constant. It's like the lease that you pay. It stays constant. Doesn't matter what the output is. So the fixed cost is going to look like this. And variable cost, such as materials, labor, the more you produce, the more labor you need. The more you produce, the more materials you need. So obviously, the higher the output, the higher the variable cost. The costs are going to pile up. So variable cost is going to look, I know that the book does it, more fancy way. They show it kind of like, show it like this. Well, we don't have to do it that fancy. What they're trying to show is that at first the variable cost is growing, but it's growing at a slower and slower rate, and then it starts growing at a faster and faster rate. But as far as we're concerned, we're not as fancy as the book. We can just say that, well, variable cost is going to look more or less like this. Okay, so we're not going to be fancy. We're just going to say, well, as output grows, variable cost grows. Okay. And now we got to have total cost, which is nothing but a summation of the fixed cost plus variable cost. Now, how do we add those two graphs? How do you add two lines or 3 or 4, however many? It's very easy. It's very easy. Basically, let me just show you, give you an example so you understand that you can add any 2, 3, however many graphs you want to add together. It's very, very easy. Imagine this. Imagine that here on this side, I have one cost. Let's say I'm going to call it cost 1. That looks like this. Whoops, here. Cost 1. And it's equal to 100. And then I have another cost. We're going to call it cost 2. And that one is equal to 200. And now I want the total cost, which is the sum of cost 1 and cost 2. Well, what would the total cost look like? Well, it would be a line here and equal to 300. Well, how did I come up with that total cost? Well, here I made it simple, but the idea is that at an output of 1, total cost 1 is 100, cost 2 is 200. So I will put the cost 1 on top of cost 2, and I'm going to get cost 1 plus cost 2, and I'm going to get 300. That's at unit 1. But at unit 2, the same thing. 100 on top of the 200 equals 300, and so on. So you go at each and every unit, and you measure what is the value of this cost. You put it on top of the other cost, and you're going to get the sum of the two costs. So that's why it's very, very simple. For example, in this case, I can just move the variable cost on top of the fixed cost, and I'm going to have the total cost. Or another way to do it is to move the fixed cost, this value here, whatever the fixed cost is, on top of the variable cost, I'm going to have the total cost. So whether you put the fixed cost on top of the variable cost, or you put the variable cost on top of the fixed cost, you're still going to get the same thing. You're going to get the total cost. And it's going to look like this. Where the difference between total cost and variable cost is always going to be the fixed cost. Okay, so it's very, very simple to add graphs. It's not complicated at all. Okay. So folks, this is what total cost, variable cost, and fixed cost are going to look like. Okay, now we're interested more into what the average costs will look like. Okay, so the average cost, we got to look at the average total cost, average fixed cost, and average variable cost. When we do averages, what we're doing is we're taking the cost and dividing by the number of units that we're producing. Okay. So obviously you can see that, let's say the total cost when I produce 5 units, total cost of those 5 units is $10. Well, on average, how much does each unit cost me on average? And the answer is $2. How did I get that $2? $10, the total cost, divided by the 5 units. it doesn't mean that each unit actually costs me $2. I just say on average, I assign equal measures of that total cost to each one of those 5 units, okay? It could be that the first unit cost me so much, the second unit so much, third unit so much, and so on. They didn't cost me the same $2, but on average, you assign equal measures to each unit. Okay. So let's take a look at average costs now. Well, average fixed cost is going to be equal to fixed cost divided by the output. You know, if I produce 3 units, is going to be the fixed cost divided by 3. If I produce 100 units, is going to be the fixed cost divided by 100. If I produce 1,000 units, it's going to be the fixed cost divided by 1,000, and so on. Now, average variable cost is variable cost divided by the output, and the average total cost is total cost divided by the output. And here in this situation, we also have the equality of average total cost is equal to average fixed cost plus average variable cost. Okay. So now, folks, what I'm going to do is I'm going to look at those costs graphically. And the one that, so costs on this axis, output on this axis. And the simplest one, the one that you should be able to figure out on your own without having any other further knowledge, is the average fixed cost. What will the average fixed cost gonna look like? Any ideas? Any ideas, folks? The
So,
average.
Straight line up, or is it flat?
The fixed cost is a straight line because it stays the same.
Right.
But remember, with the average fixed cost, you are dividing by the output, and as the output changes, as the output gets bigger and bigger, what's going to happen to the average, to the value of the average fixed cost?
It goes down.
Exactly. So it's going to be something like this. Yeah, it goes down and down. Because remember, the fixed cost is fixed. It's $1,000 is the rent that you're paying. It's $1,000 no matter what the output. If the output is 1, the average fixed cost is going to be $1,000 because you divide 1,000 by 1. But if you produce 10 units, the average fixed cost is going to be $100. If you produce 1,000 units, it's going to be $1. And so on. So as you produce closer and closer to infinity, the average fixed cost is going to go closer and closer to 0. It's going to approach it asymptotically the x-axis. So it's going to approach 0. Okay. So this is the average fixed cost. Basically, it goes down.
Yeah. Because
you're dividing a constant by higher and higher and higher numbers. Now, the average variable cost is going to look like this. What does it mean? It means that it goes down, and then at a certain point, it starts going up. So as we produce more and more units in the beginning, the average cost of each unit goes down and down and down. And then at a certain point is going to start going up and up and up. As we produce more and more units, the average cost of a unit starts going up. And now, if we want to take a look at the average total cost, all we have to do is add up the value of the average variable and the average fixed. So I'm going to put at each and every output level, I'm going to put the value of the average fixed cost on top of the average variable cost, and I'm going to have the value for the average total cost, because we know that average fixed plus average variable equals. So it's going to look kind of like this. Okay. In other words, it goes down and then it goes up. And do you notice that the average total cost here, how come it's approaching more and more and more average variable cost? Well, because the difference between average total and average variable, that difference between them is the average fixed cost. And as the average fixed cost gets smaller and smaller, obviously I'm going to have a smaller and smaller average fixed cost here, the difference between average total and average variable. Does it make sense, folks?
Yeah.
Okay, good, excellent. Okay, now I got to have one more cost that I'm going to mention, which I have not mentioned before, and it's a very, very important cost for us in economics. It's something called marginal cost. Let me erase this. MC is marginal cost. And marginal cost is nothing more than the change in the cost due to another unit of that's being produced, to the change in production. So the change in total cost given a change in output. Okay, so let me just say it a little bit even more in English than in economics. Marginal cost tells you the cost of each individual unit. In other words, with marginal cost, you're actually looking at what is the cost of the first unit, the second unit, the third unit, the fourth unit, the fifth unit. Okay? So remember I had that example where I said, well, what if we produce, let's say, 5 units, and total cost when I produce 5 units is $10. Well, then we can say that the average cost of a unit is $2. I assigned $2 to each individual unit. But if I look at marginal cost is actually going to tell me how much the first unit cost me, how much the second unit cost me, the third unit cost me, fourth unit. Okay. So it could be like this. The first unit cost me $3. The second unit cost me $2. The third unit cost me $1. Let's see, so far we are at 3 plus 2, 5 plus 1, 6. The fourth unit cost me $2, 8, and the fifth unit also cost me $2. Okay, so I have 3, 2, 1, 2, 2. Those are the marginal costs of the first unit, second unit, third unit. If I add how much the first unit and the second unit and the third unit and the fourth unit and fifth unit added to the cost, I'm going to get how much all of them, the 5 units, added to the cost. So the total cost from those 5 units is, let's say, $10. On average, each unit costs me $2. Well, none of them, very few of them actually cost me $2, but with average, I just assign equal measures from the total cost to each unit. With marginal, I'm actually looking at the actual contribution of a unit to the cost. And marginal cost is going to look also a U-shaped curve. In other words, marginal cost will also go down in the beginning as we produce more and more units. Marginal cost goes down, and then at a certain point, marginal cost starts going up and up and up. And I don't show it very well on this graph. Let me redo the graph for a second. Well, it's still not great. What I wanted to show you is that marginal cost actually should cross both the average variable and the average total at the minimum point. In my graphs, it's not going to happen very often because, you know, I do it in a hurry and I'm not going to hit the minimum. You know, it doesn't matter. It should hit the minimum. So the marginal cost. Well, now, first of all, what is this explanation for those graphs? How come in the beginning, as we produce more and more, the costs seem to be going down and then they start going up? And the reason is like this. Capital, the amount of space that you have is fixed. Okay, imagine that you want to open up a McDonald's. Okay, now before you build that McDonald's, you could build a very small McDonald's, a medium-sized McDonald's, or a very, very large McDonald's. Okay. But once you build it, you're stuck with whatever you have. So in the short run, the capital is fixed. Labor, which is a variable cost, that varies. You can hire as many or as few people as you want, but the size of the building is already predetermined. Now, I started hiring people for my McDonald's, you know, and what's going to happen in the beginning, I hired the first person. Well, the first person is going to have to do all the work. They're going to have to greet the people. They're going to have to take the orders. They're going to have to cook the food. Then they're going to have to serve it, clean up, and everything else. So I'm going to hire an additional worker. As I hire additional workers, what they're going to be able to do, they're going to be able to specialize. And as they specialize and they become better at what they're doing, what's going to happen? They're going to bring the average cost down. The average cost of a hamburger is going to be going down because each one, even though they cost me the same in terms of the wage, they will be able to contribute more and more and more because they specialize. Somebody does the cleaning, somebody does the cooking, somebody does the serving, so they become more specialized and productivity increases. And that's going to bring the cost down. Okay. Now, what's going to happen at a certain point as I hire more and more and more workers, now they're going to start running into each other. And when they start running into each other, now productivity starts decreasing. And as the productivity decreases, now the average cost of a hamburger starts going up. Okay. So we have at first going down and then going up. More productive, they run into each other, less productive. They specialize, productivity goes up, and the costs are going down, and the average cost. And then productivity goes down, and the average cost goes up. Now, let me just say one more thing about how come marginal cost has to cross the average or the total at the minimum point. Imagine this. Imagine that we're in the classroom. Imagine we're in the classroom, and I would ask everybody to go outside, and then I'm going to call you one by one, and you would have to tell me what is your GPA. And your individual GPA is the marginal GPA, if you will, because it's yours. And then we're going to take a look at the relationship between marginal and the average GPA of the class. Now, imagine that the first person comes in and says, my GPA is 3.0. Okay, so marginal GPA, their GPA is 3.0. The average of the class is also 3.0 because there's only one person. Now, a second person comes in and says, my GPA is 2.0. Well, marginal GPA is 2.0, but the average of the class is going to be 2.5. Okay. Another person comes in, says, my GPA is 2.0. Well, marginal is 2.0, the average comes down 2.33 or something like that. Okay. Do you see what's happening is as long as each person that comes into the class, if they have a GPA that is lower than the average of the class, what will they do to the average of the class?
Lower it.
Lower it, exactly. So as long as marginal is below the average will go down. As soon as somebody comes into the class and has a GPA that is higher than the average of the class, they will pull the average of the class up. It starts pulling the average up. So as long as it's below, the average goes down. As soon as it's above, the average goes up. So the only point where it can cross the average is at the point of inflection, where it stops going down and it starts going up. All right. Last thing I want to mention is this. If you use absolute values such as fixed cost, variable cost, total cost, you can certainly do fixed plus variable equals total cost, or variable cost equals total cost minus fixed cost, or fixed cost equals total cost minus variable cost, and so on. If you do averages, you can do the same thing. Average total cost equals average fixed plus average variable. Average fixed is equal to average total minus average variable, or average variable equals average total minus average fixed. Do not mix absolutes with averages. In other words, it makes no sense to say fixed cost plus average variable cost equals, because it doesn't equal anything. So do not mix averages and absolute values. Fixed cost, variable cost, total cost, that's one. Average fixed cost, average variable, average total, that's another one. Okay. So we're not gonna mix them up, because if you mix them up, they don't make any more sense. All right. Again, you're not gonna have any questions on any tests be part of perfect competition, monopoly, monopolistic competition, and oligopoly. So we will see those costs later on. So this chapter is to prepare you for the next few chapters that will be covered under test number 2. So test 1, you can disregard this for now. So look at this chapter, look at this lecture. After you're done with the test, after you're finished with test 1, then we're gonna come back to this. At this point,